Okay, good morning, students. It's a wonderful day. Today we are starting the course for 11th class. I wish you all the best. God bless you all. It's a very great day for us. Online courses we are starting, and I think you will cope with the classes that I deliver, right? With a great confidence, I start the course today, Tuesday 11th, for 11th course, right? So physics is not a very simple subject. It can be simple if you take it in that way, right? We have to deal everything. That means different subjects they are dealt with in a different way because physics is dealt in a quite different manner. Chemistry is studied in some other way. Mathematics quite different from physics and chemistry. So to deal with every subject, you must have a tactic. A trick must be there, and also your interest is very important. In physics, it is full of logic. You must have imagination. You must have creativity. You must have arguments, and all the things will be there. This is not a studying subject, but this is a learning subject. We will start with what is physics today, right? What is physics? Physics is a branch of science that deals with matter, energy, and physical quantities. Everything that we see around us, physical matter, material, the study of those is called physics. And also, it deals with matter. Sorry, matter I said, energy, because matter itself can be energy. According to Albert Einstein, matter itself is energy, right? Both are interconvertible. So matter, what is matter? If I ask you a question, even a student of class 6 algebra can speak that matter is something that has a mass and occupies some space is called matter, right? What is energy? Also, anybody can speak what is energy. Energy is something, it is a physical quantity. Energy is something that enables us to do work. Actually, work is energy and energy is work. Then what is called physical quantities? Physical quantities means all those quantities we deal with, which can be measured, are called physical quantities. In other words, we can say all measurable quantities are physical quantities. So physics actually mainly deals with the physical quantity also. No matter it deals with the basically matter and energy. Matter, what is that you know? Energy, what is that you know? What is physical quantity today you know? So physical quantity means any quantity that we measure. Means length is a physical quantity, distance is a physical quantity, volume is a physical quantity, area is a physical quantity, right? Temperature is a physical quantity, angle is a physical quantity, density is a physical quantity, right? Specific gravity is a physical quantity, velocity is a physical quantity, acceleration is a physical quantity, linear momentum is a physical quantity, force is a physical, work done is a physical quantity. All these are physical quantities, right? We must know about physical quantities. If anyone knows better about physical quantities, you know physics. So it is very necessary to know about physical quantities. That is a very great thing. So my professor used to speak that when in my times, the one who knows about physical quantities knows physics. This is what my professor said, right? So physical quantities are of two types. One is called a fundamental quantities, other is called a derived quantity. Fundamental quantities can also be said as base quantities. In the earlier days, we had only three base quantities, what is called fundamental quantities. They are length, mass, and time. Almost all the calculation we could do using these basic quantities, what you call fundamental quantities. Their units are called as fundamental units. Units are nothing but they are standards used to measure a physical quantity. Understand? Standards means just like a meter scale is there. That is a standard. Or a centimeter scale, if it is there, that is a standard. Suppose the length of a table has to be measured. It is of 2 meter length. Two times the standard is kept. First of all, at one end, then matching with the other end. Again, you will go with go keeping the meter scale. Once again, you got it measured. The length of the table can be measured. The breadth of a table can be measured using that standard. That standard is called what is called a unit. Every physical quantity to measure, there is a standard. Am I correct? There are, for example, we have 10 gram weight, we have 1 gram weight, we have 2 gram weight, we have 3 gram weight, etc. That's a standard. We have 1 kg weight. That's a standard used to measure a physical quantity called mass, right? So the temperature is measured using thermometer. Thermometer is used and it is used to measure the temperature of a hard body in terms of degree centigrade, degree Kelvin, etc. This degree Kelvin, degree centigrade, etc. are called units. So this is called unit. There are two kinds of physical quantities. Base physical quantities called fundamental quantities. Fundamental quantities are also called as independent quantities. Independent quantity means they don't need the help of any other quantities to define them. Right? To define length, mass, and time, they don't need any other external quantities. Right? So that is why they are called base quantities or called fundamental quantities. The unit of fundamental quantities are called fundamental units. What is unit? Everybody knows. Unit is a standard used to measure a physical quantity. Right? Different physical quantities are measured using different units. Right? For example, mass as a particular unit to be measured, length as another unit, and temperature another unit. So different physical quantities to measure, we need to have different standards. Am I correct? Next one is called what is the next quantity? What is called derived quantities? Derived quantities actually they can be obtained or they are defined in terms of fundamental quantities. Without the help of fundamental quantities, derived quantities cannot be defined. For example, I tell you density. There is a physical quantity called a density. Density is a derived quantity. Then what is density? Mass per unit volume is called a density. Mass, that is mass divided by volume. Right? What is volume then? Volume is equal to L into B into H. L into B into H. So volume itself is a derived quantity. Why? Because volume depends on length into breadth and height. What is length? Length only. What is breadth? Breadth also length only. What is height? Height also length only. So volume is represented in terms of a fundamental quantity or fundamental quantities. Which fundamental quantities used to define volume? Length. Right? Because length of an object is length only. Breadth is also length only. Right? Height is also length only. So volume is a derived quantity. Mass is a fundamental quantity. Right? So this is equal to mass. This mass is denoted by small m as a symbol divided by L cube. Divided by L cube. L is a fundamental quantity and M is also fundamental quantity. Using these fundamental quantities, we define density. So density is a derived quantity. Correct? So derived quantities are depending on fundamental quantities for their specification. Right? For their specification. To specify a derived quantity, we have to depend on fundamental quantities and their units are called derived units. For example, volume. What is the volume? Volume is equal to volume is also a derived quantity only. Volume is equal to length into breadth into height. Length is measured in centimeter and breadth is also measured in centimeter, right? Breadth is also measured in centimeter and height is also measured in centimeter. Therefore, centimeter into centimeter into centimeter is equal to what? That is equal to centimeter cube. Centimeter cube. Centimeter cube or meter cube. This is the derived unit of this physical quantity called volume. Right? So fundamental quantities are independent quantities. They are not depending on any other quantities for their specification. But derived quantities are depending on fundamental quantities for their specification. The units of fundamental quantities are called fundamental units. And the unit of derived quantities are called derived units. Right? As a matter of fact, we have in earlier times we had only three fundamental quantities. So using all these three fundamental quantities, we could define almost all the quantities, right? But in the later stage, when science advanced, so many other fundamental quantities also came into being. So at the present, we have 7 fundamentals and 2 supplementary quantities. 7 fundamentals are length, mass, time, electric current, temperature, luminous intensity, and quantity of matter. I will write here. So 7 fundamental quantities are there. Base quantities in all are what? 7 fundamental quantities. Base quantities are 7. I am going to write it on the board. Then you will understand it very clearly, right? 7 fundamental quantities. They are 1, 2, 3, 4, 5, 6, 7. First is length only. Next is length, mass. And this is length, mass, and time. And this is electric current. Electric current. And the other one is after that temperature. Temperature. Next is luminous intensity. Luminous intensity. And the last one is called the quantity of matter. Quantity of matter. These are the 7 basic quantities or base quantities at present that we do have. Earlier we had only 3, which were there: length, mass, and time. Right? Quantities which are independent of itself for their specification are called fundamental quantities. Their units are called fundamental units. Right? Length is symbolized as, sometimes it's symbol. Symbol. Length is symbolized as small l or sometimes capital L. And mass is symbolized as small m only. Time is symbolized by small t. Electric current is symbolized by capital I. Temperature is symbolized by capital T sometimes and theta also sometimes, theta. Right? Luminous intensity. Luminous intensity is also represented by I only, right? No problem. Current and luminous intensity, I only, right? Again, quantity of matter, there is no symbol, right? So these are the things about. Next, their unit. Unit of these physical quantities. That means length. The unit of length is what you call, that is meter. Meter, right? Mass is in kg, small k and small g, right? Sorry, meter, kilogram. I see. Kilogram. This is kilogram. The other one is second. Time is second. Time is second. And electric current is ampere. Ampere. And the temperature is Kelvin. Kelvin. And the luminous intensity is small c, small d. What do you call it as? Candela. Right? Candela. Candela. It is right? And the quantity of matter. Quantity of matter is what is called MOL. MOL mole. Then these units also have symbols as follows. Meter is most of the time denoted by small. Kilogram is most of the time written as small k and small g. And the second is always small letter s, very small letter s, right? Ampere is capital A. Kelvin is capital K. Candela is small c, small d. And mole symbol is MOL. So these are the things about the 7 fundamental quantities. What is called base quantities. So in physics, we have 7 fundamental quantities. Remember today onwards: length, mass, time, electric current, electric current, temperature, luminous intensity, and quantity of matter. Their symbols and the units of how the units are read out. Length is the unit of length is read out as meter, kilogram, second, ampere, Kelvin, candela, and mole. This is very interesting. Is second only. Second means second. One, first, second, right? So most of the time, this question I ask my students, why the unit of time is second, not third or fourth? A question I used to ask my students. My all previous students may give the answer to this question. Others cannot do that.